Okay, so it's exactly 4 o'clock. So that's good. What we have now in the schedule is a tour to the Microlab. So I would all like to invite you to join us to look at our facilities, see what we are doing there, what tools we have. But of course, you cannot walk with me. But Sean, one of you, he already went to the lab and he made a nice video of all our facilities, and he is going to show that now. See, he's presenting already. So, Sean, if you take over.
Okay. So I just send myself live. So how about now? Can you see the video?
Yeah.
Yes. Yeah.
Yes.
Okay. You hear the sounds now?
Yes.
Okay, that's great.
Hi everyone, welcome to the Microlab. My name is Shan He. I'm a PhD candidate here of the Microlab and also the ESR 8 of the Smartest project. So today, I'm going to lead you through a virtual tour of the laboratory here that we will do research about chemical material. While I have to say that it's really a pity that we cannot host this event offline and to have you here in person in our lab, but don't worry, I will do my best to give the explanation and show you the every corner of the lab we have. So let's start from an overview. If you search on Google, you will see that the Delft University of Technology is located in the southeast part of the Delft city. And if one day you visit our campus, probably the first building you will see is this one. This is the Faculty of EWI, which is the Dutch abbreviation of Electrical Engineering, Mathematics, and Computer Science. And in front of this building, you can see another one in brown color. That is the Faculty for Civil Engineering and Material Science, and that is where we are now. So if we see a little bit closer, you may find out this is a 6-story building, and the Microlab is located on the top floor. In here, we do sample preparation of small specimens and microscale characterization. And another lab that we use quite a lot is the Microlab, which is also called the Steven Laboratory. It is a rather big laboratory where we do structural tests and also concrete casting. Besides these two labs, we also have some shared facilities in this faculty, such as a CT scanner is at the second floor, and we also have some testing and curing room in the basement. So today I will start from the Microlab and then show you these labs one by one. And also I want to share with you that actually there is another way to virtually visit our lab, which is by just using Google Maps. I think about 2 years ago, our university has finished this project that provides interactive panoramas for most of labs and teaching rooms. But in this way, you don't have a guide. So let's then go back to the Microlab and start our tour today. Hi everyone, welcome back to the Microlab. So now I will give you like an overview of what we do in the Microlab and how many rooms we have and what their all functions. So you can see here, this is mainly the working area of Microlab, where we used to do mechanical tests. And in that direction, we have 3 rooms. One is the chemical room, where we use to prepare for the solution, and also we also do measurements using the ICP for the ion concentration of some. For example, the first solution that we extracted from the concrete. And we also have a sample preparation room there, where we can do caulking and polishing and also like debug characterization. And also we have a small casting room. And in direction we have several test rooms. One of them we can do implementation, XRD and TGA, and the other room we also have a environmental SEM and also a room that we can do SCP to measure the pore size and of the control system. You mentioned that in this room we do the mechanical testing, and besides that, we also have our computer here, and I will ask all my colleagues to give you a equipment in this room. And in this area, you can see we also have another strong, very similar lake one acid. And we also have a shelf here we use for optical separating. And in this area, we also have a very small handle handle casting. This one is very tiny. We put it, we even put it in an IPM chamber. And we usually use it to cast like for example, single fiber test and everything with very small specimen. And it has a 10 Newton capacity, very precise and very expensive. And so in that area, we have some shelves that we store material, and then we go to the printer, the medium size. And we go on here for crazy plastic, and so this one here is the plastic. This plastic used with more, and yeah, our exhibition on our there show in this batch is we put some up to the tier. Also, we use the corrosion test, and in that bracket, there are also machines that work testing the particles and distribution. So this is now all about the area. So now let's move to the chemical room. I think all my colleagues in here is very familiar with chemical. So I'll be able to help you with this. Let's go find Louis. Hi Louis, good morning.
Hello Sean, how are you doing?
Good. Can you help me introduce a bit of this lab?
Yes, of course. So, hello everyone, I'm Louis. I am a PhD researcher here at TU Delft, and my topic of research is a microstructure modeling of highly activated materials. So we are here in the chemical room of the Microlab, and here in the chemical room we do all of the work that is related to chemicals. So we do sample preparations, we prepare our alkaline solutions as activators for our activated materials. We deal with small quantity of materials, and I will show you around a little bit of what that we have here initially, the centrifuge. So if you need to work with materials that you have to clearly separate liquid portion from some solid portion, or separate even over phases in your material. We are preparing samples to be measured in the ICP, which is a machine that can measure the concentration of different ionic species. And what I mentioned about chemical room is that we had to prepare, for example, samples of sodium hydroxide and a small quantity of powder, so 1 gram, and that's why we use the chemical room for small quantities of samples and to deal with these chemical reagents. Here we just have a regular chamber where you can collect all the fumes that might be generated from the chemical reaction if you are dealing with acids or bases or any other chemical compound. That you will see. And I think it's interesting to show what we have here in this room. So we are entering in the second room of the chemical room. And in here we have some more interesting equipment that might help the research. In here we have the surface area analyzer, so it's a nice thing that we use machine. And you can use this machine to measure pore size distribution, especially if you're talking about nanoscale pores, for example, porosity of gel. And you can also measure surface area with this amazing technique. And in here we have the ICP OES, which is the optical emission spectrometer, and you can use this machine to measure the concentration of your species in your pore solution. So you can either work with the extraction of the pore solution of ardent cement phase or ardent water, or you can work with highly diluted solutions to just measure the dissolution rate of different species in the mix that you are analyzing. And in here we just have some more basic equipment. So we have an oven that goes up to 1100 degrees. We have a vacuum oven, which is necessary to prepare samples depending on which type of technique you are going to use. And we just have some small oven which goes up to 100 degrees to dry your samples. And as I mentioned, here in the chemical room, we deal with little amounts of samples, so we have our specific balances that can weigh up to 300 grams or 500 grams to do very analytical and precise research and investigation. Thank you, guys. I hope you are enjoying this school that is being organized by CSL. And if you have any questions about how to use chemical room, you can either look for Sean or ask for my contact or for someone else, because we'll be glad to support your research.
Thanks, Louis, for the perfect introduction of the chemical room. Now we are in the sample preparation. So in this room, basically, we usually mainly do clocking and branding, polishing, and in-house preparation to prepare our specimen before the next stage characterization and packaging. So here, the first one is the film pool that we usually do some gluing and also the in-house preparation in here, and the use of the capsules outside. So it's going to from the second in those areas. And over here, you can see the saw. And actually, in this room, we have different sizes of the saw, so we can cut them for big, small. And this is for the big one that actually has solutions. But over there, so they cut into the shape that you want. And over here, this ultrasonic laser that we use in specimen. For example, for everyone who used to do SDM, we will have to do this. And here is the render that you can select it, because we know that was a great specimen, usually a practice surface is not that flat. So the first step has to be to flatten it first. And over here, this is a very tiny size of saw that we usually cut our specimen to millimeter size. And this precise one. And over there, we have the polishing machine. And besides that, you can see we have many grades of those polishing stones and also the polishing paste that we use in combination to shape the desired surface finishing level. So here, again, this is the fluorescent spectrum machine. And I think also I think something you should know is that the reason why we call Microlab is not because the size of that is small. It's because we focus on understanding material behavior in a micro scale. And you always want to do that. You have to prepare a specimen in a very careful way. So your characterization in the microscope is precise and in a very high standard. So this is some of the equipment that really help us to achieve that goal. So basically, this is dicing saw. This is originally designed and used to cut wafers. So you can imagine that this is much precise. With this machine, we can prepare micro cantilever and also to prepare the very small specimens that we use for CT scanner. And so this is what we have in this preparation room. So now let's go to the other side of the Microlab, where we have the mercury room, mapping, and also the ESAM room for the microscale imaging, and also the room for other measurements. So now you can see we have the room here. So this is our EM room. As I mentioned, that we have an experimental scanning electron microscope, and where we use to observe the microstructure. And beside this is the mercury room that we usually deal with experiments with mercury, for example, IYP, where we can measure force distribution. So now we are at the ESAM room. As mentioned, we have environmental scanning electron microscope, so where we use to observe the microstructure. And this one, the special thing is like this, the environmental scanning microscope, SEM. It's different from the typical UV vision one that it doesn't require a high vacuum in the chamber. So that allows us to observe our specimen in aqueous environment, or also in, for example, that is very helpful. We want to observe the microbiome like bacteria, and also it's very helpful if you want to see the property of certain crystals. So in this case, we also have to microscope, and that could help us to give the first observation of the microstructure. And also, if you want to see the minerals involved in your specimen, this is also very helpful. So So let's then go to the next room. So in this room, we have basically three equipment here. The first one is the thermogravimetric analyzer, which allow you the study of the mass changes and the thermal effect within a certain range of temperature that presented by the user. It can help you understand that what's the chemical composition of specimen. And over here, we have an X-ray powder diffraction, XRD, which is very versatile and powerful constructive analyze method. And basically, it can help you to quantify and determine different forms of crystalline and then compare your results with a database or the global recognized pattern, that you will roughly know the chemical composition of the specimen. So over here we have this is the black box inside of it. It's not an enter because now it has expressions of the open data. So this can help you to measure the non-organic the proteins of the specimen. For example, like a hardness or like the boson, elastic boson. So with the results from this indentation, it can help you to characterize the non-organic materials so you understand from it. Then you can also use this as an input for model in order to simulate physics material performance at a higher level. So about this machine, let's go to the next one. So now you have already visited every room of the Microlab. So let's now go to the safety lab and the basement. I will show you our specimen and also our specific next room. Let's go. Hi everyone, so now we are at the comprehensive group of the safety lab. So in this section, we have a live cell that we use to store and measure material. It's very convenient system that includes the keys that have material you want and automatically give you material. Well, this first cement, dry powder here like cement and size and inside. Also like material like the fly ash. And in this direction, this is our real casting area. You can see we have inside. This is a big one for the concrete. So gravity based mixer that we use to have also separate some of the parts. And this is the oven that we use to dry out the specimen. And over here you can see the table. This will measure the fresh protein of the skin. And over here, there's a super mixer, two mixers. This is one for big one and the small one that we use to cast all the art. Like myself, I cast a lot of the engineering composites. This is always the mixer that I use the most. And in this direction, you can see this is the we and over here is this rubbish bin that we dispose of materials that we handling. And here is the well that we dispose of fresh material. And in this division, there is a preparation table that we also use from the company that we have to practice with the preparation unit. So in this region, we can be our area where we do the demolding of the so there are preparation And let's move to our next one. So the next one is the TSTM, which we call it the temperature stress testing machine. In that one, you can adjust the temperature so that you can measure the degree of stress that generated with the specimen. So let's go and take a look. So here we are already in the room. As you can see, this is also the same setup for different types of specimens. This is the direction you can see through the multiple sample preparation. So then let's go to the next one. So this room is a little bit different from the previous one. In that one, we already set different temperature. For this one, we always start with the temperature to be 20 degrees, and also the relative humidity at 50%. We already store some of the material here, and we also use some of the tests very sensitive to this condition. As you can see over there, there are some quick tests ready, and also we have green case that also extract ready on the bottom and use the table. And besides that, we also have some durability test that I'm doing. This is the probability test, and that one is special. This is the weaker test machine. So the machine can help you to assess the setting time of your mixture, where it's water or experiments like reheating. You always want to know the open window of your mixture. So this is about this basement. Another thing I have already showed you what we have in basement. So let's then go back to the Microlab. Welcome back, everyone. So I hope you enjoyed the tour so far. And I think after I gave a rather general explanation about those equipment, you may want a more in-depth introduction to some of the equipment. So in the following, I will ask some of my colleagues who do self-healing related topics to give a more specific explanation and introduction to their topic and also the equipment that we use for their own research.
Hello everybody, my name is Claudia Romero Rodriguez. I'm a PhD candidate at Microlab in Delft, University of Technology. And my PhD is about optimization of self-healing mechanisms in concrete by modeling and testing. Whereas the main focus of my PhD is actually the modeling part. We need to put quality input in order to actually obtain quality output. So I did a lot of experiments for both input and validation of my models. And my favorite machine in the Microlab is actually this one here. This is a lab micro CT scanner, and I use it a lot either to find the transport properties of the materials I was evaluating or to assess healing efficiency after the healing period. So if you come a little bit closer, then I can show you a little bit how the machine works. So this is the inside of a lab CT scanner. This scanner in particular can obtain resolutions of about 500 nanometers, which is actually quite nice. Here is the sample holder. You put your sample in here, and then you have the source part from which X-rays are emitted, and the detector. And the beauty of this machine is that you can see what is inside the sample through the interaction between these X-rays and the sample material. So in this case, we have quite smaller samples, so bear with me. So we prepared these microbeams. So this microbeam is prepared from the same material that I had the samples for validation of the self-healing. And then it has a cross-section of 500 micrometers by 500 micrometers. And then we scan this beam. Basically, I do the same technique. I scan the beam at a dry state and then at a saturated state, and I can map the porosity in the microbeam. In this case, we prefer to use smaller samples because the smaller the sample, the higher the resolution that we can obtain potentially, depending on the CT scanner, of course. In this case, we obtain a resolution of 500 nanometers per voxel. So then we simulated the permeability in this pore structure that we found with the CT scanner, and then we could also obtain tortuosity, and this gave us the input parameters that we needed for the transport model.
Hello everyone, I'm Zayuan, and I'm a PhD candidate for Microlab in TU Delft. My research topic is about the application of 3D printing technology in vascular-based self-healing concrete. This is the 3D printer in Microlab, and we can use this equipment to print many things. For example, print some small things for other research in our group, and also we also use this to print some other structures which can act as reinforcement in the sample. But in my research, I use this equipment to print some vasculars. And this is an example. Currently, many people use the glass tube to act as the vascular in self-healing concrete. But the glass may react with the cementitious matrix, which will have adverse effect to the healing efficiency. In my research, we create some vasculars, and then after we carry out some experiments, for example, 3-point bending, we can then inject some healing agents into the sample, and then the healing agent will flow into the crack through those vasculars, and then the crack will be healed.
Hello, my name is Yidong, and a PhD in Microlab. Today I will give you a brief introduction of the nanoindentation and also its application in the self-healing materials. As we all know, the nanoindentation is a widely used method to investigate the local mechanical properties. And one of the main self-healing strategies is to embed the microcapsules into the material, which contains some self-healing agents. So by breaking the capsules and releasing this self-healing agents, we can achieve the self-healing. So it's very important to understand the micromechanical properties of the capsules itself and also its bonding with the vocal materials like stem paste. So we're using the nanoindentation to perform some indents on the capsules and also the interface between the capsule and the vocal materials. We can know the micromechanical properties. So it helps us to evaluate and properly improve the efficiency of the self-healing. And also they can also serve as the inputs for our model. And that's all. Thank you.
Hello, my name is Shishi. I'm a PhD student in Microlab. My research topic is self-healing in output. And to achieve self-healing in output, two technologies are used. First is the capsules. This is the calcium alternate capsules, which are prepared by encapsulating the bitumen rejuvenator inside the capsules. And when crack happens, the crack penetrates through the capsules and release the rejuvenator. So the rejuvenator will seal the crack and heal the crack. The other technology is the induction heating. First, I have to mix the steel fibers together with the asphalt concrete, and then the machine behind me is used. So the step is very simple. We put the damaged asphalt concrete below the induction coil, then we turn on the induction machine, and then the induction coil will gradually heat up the asphalt concrete, and also cracks will be healed by the increased temperature from the injection heat. So by combining the two technologies, the cracks in absolute concrete will be healed more efficiently, and with this method, the lifespan of the absolute concrete will be extended. Thank you very much, and hope you enjoy this training.
Hi everyone. So I think this is maybe all I have today. I hope you enjoyed this lab tour. Since Louis has mentioned that if you get any question about equipment here, you can feel free to contact us. And like me or anyone in this staff, you can find our email on the website. So thank you very much, and hope you enjoy this training school in this week.
Thank you very much, Sean. I think it was a very interesting presentation of our lab to show all the equipment. It sounded a bit like you were already in the swimming pool working on the project, but yeah, you told me that there was some problem with the sound, but that's why you put the subtitling, that at least it could be followed, and I think it gives a very good overview. So nice job done, John. This brings us also to the end of the first day. So we'll continue tomorrow morning at 9 o'clock. I think today was already very nice with the nice presentations on presentation and publication. And we saw the nice video that Sean made. I hope you enjoyed it, the first day, and looking forward to see you back tomorrow morning. Don't forget to also work on your project in your teams, because you have to present on Friday. Also look in the Teams folders for the questions that some of the lecturers put, questions that you have to think of during your evening tonight, so that you can discuss them tomorrow with us during the lectures. So have a look there, and then I wish you a good night and see you all back tomorrow morning. Bye.
Bye.
Bye-bye.
Bye.
Bye. Thank you.
Bye.